This is an introductory session to Docker. I will give you a brief overview about what Docker is and why we should use it, but that will be very brief. Idea here is to, set up the Docker environment, run your very first container from an image. Possibly, if we have time and enough interest, we will build an image. If we have even more time and interest, we will build an image from, not from another image. So first we'll try to build an image out of an existing image, and then we'll try to build an image from bare files, right? So that's the basic idea. So we'll do introduction. Okay. Then we'll do installation. What else do we want to do? You guys have to come up with the agenda. This is going to be a bit interactive. Nobody wants to do anything. I like this workshop already.
Show us how to create it.
Right, so we'll create an image from another image. Tell you what, we'll try to push image to a public repo so that others can download collaboration. If we are able to achieve all this, we'll create a simple image from, bare bones. Works good?
Yeah. Doing some networking stuff.
I will do the basic stuff. One more thing I think we should do is does this sound good? Okay. We'll try to achieve at least first 5. Let's see if we can achieve the 6th one. Right? Okay. This is me. Hi, my name is Aditya. I work I contribute to Fedora admin team, mostly towards easy fix tasks and Ansible migration and all those things. I have contributed a bit to the default Fedora Docker example package. I have written some small Dockerfiles, and I help around as much as I can. It's very little. Anyways, so these are the topics. I'm gonna cover them in very quickly in like 5-10 minutes, and then we'll move ahead with hands-on stuff. The problem which we face today, as all the developers, testers, sysads, is that your production or whatever environment you're dealing with, it needs to be homogeneous, right? Your production, the way it is today, should be tomorrow. The way your QA environment is, if something works in QA environment, it should work in production, right? It should not break going up this cycle. It should always break downwards if it has to. That's one thing. Assuming that something actually broke on somebody else's machine, you should have capability to port that entire environment for further testing. For example, if I wrote a simple code, it works on my machine, I gave it to my colleague, it broke there. My colleague should have a capability to wrap up his entire environment and give it to me so that I can debug. I don't want his laptop and hamper his work so that I can debug. So this entire problem is addressed. For those who have worked with hypervisors, they would know that hypervisors eat a lot of CPU cycles and somewhat RAM. So that problem has to be addressed. And then again, the classic problem. Hey, that thing works on my machine. That's not my problem, right? So we have to address that problem as well. Okay, so what is Docker? It's basically LXC with batteries included. How many of you know what LXC is? Okay, fair number of people. Right. So LXC Linux containers they are kernel C groups and namespace implementation, which means that they provide you isolation. And your PIDs and your resource allocation, as much as possible, would be in a separate namespace, right? That helps in segregating different environments. It uses AUFS. AUFS is another union file system. AUFS means that when a machine boots up, it boots up by default when any Linux, not only Docker, when any Linux machine boots up, it boots up as a read-only file system. Once it has that, it has totally booted up, it acquires a read-write state, right? What Docker does is that it boots up it as read-only, but it stays as read-only. It applies a union layer of write file system. So that's how it gets into read-write mode, right? That helps in speeding up a lot of things because you don't need to convert a file system from read-only to read-write. You just add a layer. That's faster. It's portable. Registries are awesome. Registries is like repository. Portable in the sense that I made a container, I did some changes, I added my new code, I can ship it to whoever I want easily. I have to do minimal efforts. So that saves time. That helps in making sure that environment across all the machines, all the servers, QAs, everything is consistent and it works. It should work. And why do we want to go with Docker? Docker is very lightweight. Right? It's extremely lightweight. It boots up in seconds. I'll show you a demo, and I can guarantee you that it will boot up in less than 5 seconds. 5 seconds is actually too much. If I have a image thin enough, it will boot up within a second. So that's how fast it is. And of course, everybody loves an environment which is fast, right? It's fast. Okay. You can incrementally build, revert, and reuse your container. So, since I told you that everything is layered, right? Now, say you made some changes today, created a new container out of it, created a new Docker image out of it. You send it to the testing where it failed. You do not have to create everything from scratch again. You can do a revert of the container. It's very similar to what you do with Git, right? You can create a diff. You can commit changes. You can revert changes. All those things can be done with Docker. So basically, your entire infrastructure becomes code. It's very easy to revert and share. And there's an API. Docker provides you with the REST API. You can manage your Docker servers remotely. You do not need to manually SSH into the server and do things. There is a REST API for that. That helps as well. Why not LXC or why not virtual machines? Virtual machines consume a lot of resources. So there was a study done by Gordon Russell from IBM. He presented it in Dockerfile this year. So according to the data he found, he booted 15 machines. 15 Docker machines took 20% of the CPU, whereas 15 virtual machines took 70% of the CPU. That's massive savings. Imagine what you can do with that kind of computing power. Cool. Memory usage per Docker machine was just 50 MB, whereas per VM was close to 300 MB. So that means you can boot a lot more machines. You can do a lot more computation using the same amount of resources that you have. Cool. If you want a more comprehensive overview of this, I would really recommend to see the talk by Gordon Russell. It's there on YouTube. Just watch it. It's an amazing talk. Why not LXC? LXC, so Docker has better tooling around it. It has evolved a lot. Some people would try to build toolchains around it. That's what Spotify did. What they did was they thought, we have Docker, we have LXC. Let's start with LXC and we'll build our own tooling around it. So when they worked for months and years, after some time they discovered that they had created a very happy Docker. And that's what they admitted in one of their talks, that after so much hard work, we actually managed to create a very happy Docker. We should have stick with Docker. So that's what I'm trying to tell you, is that ecosystem is already so nice around Docker that probably you shouldn't, unless you are developing something which isn't satisfied by Docker, I would recommend strongly to stick with Docker. Okay, so let's try out stuff. Cool. Anybody has any questions till now? Maybe we should, clear it out before we go. Okay. Is it visible? It's visible, right? Okay. Okay. So first off, we will install Docker. How many of you already have the installation? How many already have done the installation? Okay, you already have it. Okay. Those who don't have it, that's the thing. One thing which I would want you guys to know, that Docker doesn't work on 32-bit. If you have a 32-bit machine, this would be a demo for you, not a workshop. Really sorry about that. For Fedora, it's not supported if you are on a. For Fedora, it's not supported if you are on an older release than 19, I think. So only 19 and 20 are officially supported as of now. Other than that, yeah, don't do yum install Docker. Do yum install Docker -i. Yum install Docker is something else. It will give you totally different thing. So yeah, don't do that. Yum install Docker -i. Done? Are we done there? Okay. Just started. Systemctl start Docker or service Docker start, whatever you prefer. How many of you are sys guys, and how many of you are, what's the other thing? Systemd guys. Systemd? Okay, I got a few hands. Systemd. Okay, for systemd, system start Docker, systemctl start Docker. Sorry, I keep on forgetting stuff. Okay. So next up, what I'm going to do is, I'm going to pull the Docker image from repository. One of the Docker images from repository. Just like we do yum install something, we do Docker pull something. So Docker pull is going to go to the default repository of Docker, which is hosted by docker.io, and it's going to pull images. Now I would love to do Docker pull Fedora, but that's going to download 300 MB of image. Actually more than that. Okay, so I would love to do Docker pull Fedora, but that would do a massive amount of downloads, and all of you doing Docker pull Fedora together will be a problem, I suppose, for the networking. So I have made a very small image, which is like 1 MB. So you can do this. I already have it, so okay. So this image is just 1 MB.
This is normally done as root or as a different unit?
It's done as root. So because you need access to kernel namespaces, you cannot do it without. Because normally it's done with kernel namespaces, you cannot do it without root. Or alternatively, you can add a user in Docker group. So that's possible. But again,
For this, we'll do it.
yeah, for demo you can use it, but I would strongly recommend you put a user in Docker. Okay. So it's a very small image. It just has BusyBox in it. Few commands will run like ls touch. That's all it's gonna work. Nothing fancy. By the way, that's the 6th code. If we can make this, alright. Okay, are we done with this? Everybody is like on the same page. We got the image, right? Should I move ahead? Okay. So now just take a second to see what it did. So Docker has a convention. All the repositories which are maintained by Docker guys or which are official, they do not have. Yeah. Which are official, they do not have this convention. Like mine is admania/fedora busybox. This signifies that this is not an official repository. It's a user repository. Username is admania slash the image name. Had it been an official repository, it would be Dockerfile fedora or Dockerfile something. There wouldn't be any slash in there. So this is the best way to recognize if the image is official one or not. If the image is supported, or if the image is built by Docker guys, or a guy like me. Cool. It downloaded a image with ID 605BFCG. I'm sure you guys will get the same ID, right? Okay. Okay. This is better, right? So I have a lot of images, but so if you can have a look, the repository admania/fedora busybox. There's a tag latest, then there's image ID. It was created 2 weeks ago, and the size is 1 MB, right? Now, if you see down on it, there are certain images from Fedora repository, right? The tags are different. If you look closely, there's a tag 20, then there's a tag Heisenberg, there's a tag latest, and all of them have the same ID, right? Everything with tag 20, Heisenberg, and latest have the same ID. This means that if I want to pull up, if I do Fedora tag Heisenberg, or if I try to pull up Fedora tag 20, I will get the same report. I'll get the same image, but not so. But latest tag, I suppose, would keep on changing, right? For example, after the 21 is released, the tag latest will point to the Fedora 21. So this way, tagging can help. So we do tagging to get the appropriate image. Okay, so I did a Docker PS command. Docker PS will show me what all containers I have running currently. I have nothing running here. Right? Are we good? Okay, so let's start our image. What am I doing here? I am doing a Docker run in interactive mode. I am asking it to allocate me a TTY -D. The image which I want to start is with whatever we downloaded, admin/fedora visbox. And the executable which I want to run is spinsh. Right? So it will drop me in a shell. It returned immediately, so boot time is like very fast. Okay, so let's see what's there. That's the bare minimum thing, I suppose. Can you guys see it? Okay. Okay, I created a file in there, right? So now I'm just going to exit. So it's not running anymore. When I exit the interactive mode, I basically shut down the container. How do I get it back? Okay. Right, so now Docker ps -a, what it does is that it gives me a list of all the Docker containers that I have run over the period of time, which are not destroyed by me and are in stop state. So I got the ID from Docker ps -a. Now I'm just going to start the container again. Okay. What happened? How do I know that it actually started? Can anybody help me with that? Yeah, I'll do Docker ps. Yeah, it's running. See, cranky Archimedes. So, Docker has the concept of naming the containers. You can name it yourself. So, for example, if you're running that awesome Python script, you can name it that awesome Python script, and use that. Otherwise, it generates the name automatically and assigns it, so that you don't need to remember the container ID, which is a very long cryptic number. You can just remember the name, which is cranky Archimedes. I'm sure that's easier to remember. Okay. Can anyone tell me how do I connect to the Docker now? Yep, that's right. So we do a Docker attach. Do cranky Archimedes. Yep. See the same file which we created there. So you can stop Docker, you can start Docker very quickly. It takes very less time to shut down and bring back Docker machines. That's a very major advantage of how this is done. Okay. How do you get out of Docker prompt? Hit Control P Q. Control P Q will get you out of the current Docker. It's like screening detach sort of thing. And then you can just stop this Docker. That doesn't help. Oh, okay. Okay. That didn't help my point, but still. Right. So now you know how to pull a Docker image, how to start it, how to stop it, how to attach, detach, all those things. Anybody has any questions till now? let's assume that I'm too awesome. That always helps. Okay. So let's move on to the second one. How do you ship? So you have this image running, which I run again. So you have the image running. Now you want to ship it to your colleague. How do you do that? Right. That's a question. First off, you have to create an image out of this, and then you can ship it. So all of you, I'm sure, are aware about how you guys do git commit and git push and all those things, right? So what I'm going to do is I'm going to start over this container. Okay, so I'm in the same image. My target is to make sure that I have to ship an image which has this file ASDF. Okay. Yep, which has this file ASDF to someone, to my colleague or my friend or whoever. So what can I do? I'm going to commit this stage of Docker, and commit will have all the files. First thing is that I can see what all things have changed using docker-diff command. Docker-diff will tell me that there have been these two files which I've created recently. Ash.history. Ash is the alternative of, it's a shell. Ash is essentially a shell. And then I've created a file ASDF. So these two are in the diff. Now I'm going to do a docker commit. Let me put some tag. Okay. Now, if I do Docker images, I should see this new guy here. So I have called Docker demo here. Now, if I boot from this particular container, this particular image, Docker demo, flock demo, then I should have that file with me, ASDL, which signifies that, okay, we have got a commit there, right? And now what I can do is I can take this container and ship it to whoever I want. Sounds good? So that's one problem solved. But I cannot do this using Docker's repositories. Can anybody suggest a reason?
Security?
Yes, but even after signing in, I won't be able to do it just like that. The reason is that Docker repositories expect the names in a certain convention. Remember the convention which I showed you, username / the tag. Here I just did the tag, so it's not going to accept it. If you have your own private repositories, that's fine, that's good to go. You can use this, right? So that's one thing which you need to keep in mind, that whenever you are doing any public exposure of your image via Docker repositories, always make sure that you have it username slash the name of the image. Cool? Okay, we have got the commitment done. Right. How many of you are interested in knowing how to build a machine, how to build a Docker image from a Dockerfile? Okay. Cool. So I'm just going to write a very simple Dockerfile, something which is already committed into Fedora's Dockerfile example, so that it's easier to, it's fairly easy to understand actually. So that's the one which I wrote. First one is from Fedora. What this means is that I will use Fedora's default. I would use Fedora's default image as my base image. So one thing which you should understand about Docker is that Docker does everything in a layered fashion. That's what AUFS is all about. Let me show you a diagram. If I can. Right. So here's what Docker containers look like. What happens is that there is a bootfs, there is a kernel over which there is a bootfs, right? Inside the bootfs. Now, the example is of course of container, but so the OS layers goes over that. Over the kernel image. Then, for example, if you want to add some basic software like Emacs or Vim or something like that, you can have another layer on that. Next, you want to add Apache or maybe PHP or Python or GUnicorn or whatever you want. You can add another layer over that. And maybe then your custom code goes, your application, that will be another layer over that. So this layered file system is known as AUFS, another union file system. Fedora doesn't use AUFS, by the way, just to be clear. We use thin Gaussian device mapping, but this is what we are going to move to eventually. We had to do that because just to maintain the backward compatibility, but this is what we are going to do maybe in a year or something like that. Anyway, so we do have layered structure though. What this layered structure does is,
well, we are going to do it if AUFS is merged in kernel, so it depends on this condition.
Yep. I think they are. The port is.
They are trying, but still isn't in kernel. So
I hope it will be there with 318, I suppose. Let's see. Yeah. So what was I talking about? Layers. Something to do with layers. Right. Okay. So right, what happens with layers is that the reason why layers are helpful is, for example, you maintain. At Fedora, we maintain a lot of Flask applications, right? So what we can do is we can create a layer up till Flask, which can be common, and after that, whatever application we add upon it, they don't need to create those layers again. So layer 1 would be bootfs, layer 2 would be Fedora, layer 3 would be maybe Flask along with some others. So we can. Okay, I think so. Right, absolutely. Hello. Oh, it's back. Okay. Yep. So the layering helps because now so layering helps because what happens is that we can have a lot of layers in common and then just one last layer or maybe last couple of layers where we can actually have the differential code. So that helps us a lot in maintaining a common ground.
Can I update the base layer
Yep. So what happens is that if anything has updated in any of the layers downstairs, downwards, all the layers above that get rebuilt. So you cannot just update the layer down.
Yeah.
No, you cannot just update the layer down. You have to update the entire stack.
And then build it again.
Yeah, and you have to build it again. The reason is that each layer is an image in itself. So you can pull out any layer and work on it. But if you just update one portion of it and don't update the other one, then there might be inconsistencies. So you have to update the entire image. Okay, now that we have got this in place, we will so this is a simple Dockerfile. So from Fedora is because I want the base Fedora. The second line is mandatory. You have to specify a point of contact, whoever is going to be maintaining this Dockerfile. Now, I'm doing a yum-y update. So as soon as my Docker will start, my Docker building process will start. It's gonna pull all the packages. And then I'm going to install Redis on it. I will expose port 6379. Exposing port 6379 means, okay, by default. Hello. Okay, so by default Docker doesn't expose its ports outside. By doing expose 6379, I'm telling Docker that this port needs to be exposed so that others can access it, right? And then CMD Redis server. Redis. This command will be executed as soon as the Docker machine starts. Docker container will start. So I will have Redis running in no time. So this is the idea. Okay, you don't need to write the file actually. I have put the file there. It's in Fedora repositories. You can directly go to that short link and get the file, get the Docker file. You can Docker build. You can give the path of the Docker file. It can be a path on your machine, or it can be a URL where the file can be available. Did anybody try this command? Okay, did it work for you?
Yeah.
Cool. So, did it build or is it still building?
Yes. It's downloaded the.
Let me also run this. Did you see that it's almost instantaneous on my machine, but while on his machine it will take some time? Right? Can anybody suggest a reason?
Because you have already downloaded.
Yep, that's right. Because once you have created it, it will keep a track of what all intermediate containers you have. So this is very helpful actually. For example, say that step 4 failed somehow. So what you can do is, you can get the container which was built till step 3, A8, D3, D6 guy, and then you can just run it and try to debug it. Right? So every step there is an intermediate container which is created. Since I already have all these containers, containers created, it's very fast on my machine. Okay, are we done then?
It's an image, it's not a container.
Oh, right, sorry, my bad. I need to do a Docker run. So I'll just do Docker run this. I don't need a TTY. Right? So Redis is running in that. Okay. Yeah, this is your review, right? So you see that the machine is running 4845 something. The command which is running in foreground is Redis server. The port 6379 TCP is exposed, right? So you can you hit 6379? Try doing that. Try doing Telnet or Redis CLI or something. I think it should fail. Yeah. What happened there? Okay. Can somebody suggest what's happening here?
You need to put the number after it, I
Like this? No?
think. Like that.
Oh, I forgot something. Right. What happened here is that while running the Docker machine, while running the Docker image, I need to specify what port I want to whitelist so that it can be made accessible, which I forgot to give. So, let's do it. Okay. Maybe this guy. Right, so we don't have anything running right now. Right, so what I'm going to do is What was the code?
No, this won't work.
Why not?
Well, if you specify port in the Dockerfile, it will export that port from the Docker container. So I think there's a problem somewhere else, probably in Redis or something, because it should work as you tried it. If you want to use port option in Docker run, it just means that it will redirect port from the host machine to the port in the Docker container. So you could specify that you want port 80 redirect to containers port 6379. This, as you tried it, should work.
It should work, right? That's what
That's probably misconfigured Redis or something like that.
that will land us in problem because this is committed into Fedora's official Dockerfile example. Probably the routes are messed up. Okay, I'll have a look into this and we'll get this fixed. But this is how you create a new image from a Dockerfile. You can do a lot of things. For example, if you have some configurations that you want to copy from your local machine to a Dockerfile, that works. There are commands for that. There are commands for exposing a port. There are commands for installing. Pretty much everything that will work in a shell script in a way or other will work here. Right? Now, this file was written a while back, so this is not the best, I would say, the way to do this. Right now, it should be given as a list and not text like this. That's the best convention to do it. So, before you actually try to commit something in production, please make sure that you go through those guidelines first on how to write a good Dockerfile. The new examples, the new things which are being committed into Fedora's Dockerfile do have that convention, but that would be a bit more, strange. Okay. Right, we have done 1, 2, 3, 5. 4 is left. Push image to a public repo. Okay. To push image to a public repo, we can all try to push image to Docker's registry. So I think that's hub.docker.io. How many of you have an account there already? Hub.docker.io. So those who don't have it, you can just create it. It's easy. And we can try to push one of our images to hub.docker.io. Cool? Sounds good? Let's push the flock demo image. Okay, right now if I try to push it, I think it would fail. Because my convention is wrong, right? See, it tells you cannot push a root repository. Please rename your repository to this. Okay. So you have to make sure that you follow the proper convention. Unless you have a private repo, then you can pretty much do whatever you want. Okay, let's do a few more things before we actually start to push stuff. I forgot to request for a 31. Right. So it's a basic BusyBox image. Let me see what else I can do. Touch. Can I go by code? If I can get code. Okay, so this time I'm going to create the right image. I'll just do Docker somewhere. Okay, this sounds good. Right. So now if you see that first one, it said image already pushed, skipping. So what happened there was that my BusyBox image is already skipped, and as I told you, everything is in layers. So till my BusyBox base image, everything is already there on the repository. So it will only push the diff which happened. Now what was the diff? The diff was diff was just a file, flop demo and ash history. Right? There have been changes to ash history. There is a new file known as flop demo was created. Cool. So I posted. Now anybody who wants to verify that my file is there can just do a docker pull admenia/flop demo and it should work for it. So that's how you can easily share your entire environment, your application with your colleagues, or you can ship them off to test environment and then promote them to dev environment. Just the diffs are shipped, so the entire process of shipping code becomes very fast. Since it's lightweight, you can run more of them in a single server, and that actually helps in reducing costs and saving time a lot. Okay. Right, so we have done the first 5. Anybody has any questions so far?
Yes.
Yeah.
Could you zoom in a little bit on the network?
Right, what exactly about the network? See, I'm actually
Well,
not.
normally a single node has one system idea.
Right.
And it only has 65,000 and some sockets. I can do many lightweight systems on that run network services. How am I supposed to make sure that every one of them are connected to the network?
Okay.
So this is 800 web servers, for example.
Right, so you are saying that you're running 800 containers, 800 Docker containers
800 containers.
over on a single machine, and then
Single machine.
what will happen to the network? That's what you want to know. So let me put it this way. First thing is that the entire network is NAT, the internal network that's going to be NATed. So inter-Docker communication shouldn't be that difficult. Now the thing goes that how will be the availability of all the ports? That's the question, right? Okay, I haven't run into that kind of scale yet, so I'm not entirely sure what's going to happen. But from what I'm assuming that once you have that 65,000 limit hit, you may not be able to open anything more.
No, you will. Yeah, resource not available.
Yeah, resource not available, you get that. Again, I haven't actually ever hit that limit, so I'm not sure entirely if that's going to happen.
Well, if you have 4 CPU sockets at 768 of graph,
Yeah, then
and
pretty much.
Running some Docker.
But yeah, what I'm thinking is that when you run 800 of the Docker images, probably you're going to hit CPU first. Probably, depending on what kind of load you're running. Or maybe RAM.
I'm just, like 800 is just a number I would.
Right, I understand. But going forward,
So
usually.
I'm supposed to give the Docker host multiple network IP addresses so that I have multiple voice forms that I can add, or can I make Docker bridge this instead of private networking?
Bridging is not directly supported as well. Again,
Can you repeat the question? I will be ready to go.
so the question is that instead of putting Docker on NAT, can you put it over bridge or something like that?
Yeah.
Docker takes care of networking itself, so I'm not sure of the implementation in Docker itself. It creates Docker 0 device, and then that's the gateway for the container.
So you get a very
So then I lose that one, the
It-
application, I lose one, and I
Came
lose-
back.
This is all third party systems.
I'm pretty sure, yeah.
But still, that limit of 65,000. Okay. The limit of 65,000, I think once it's hit, you will get resource not available. As far as I know, if you have a single IP server, there is no way around it. You will have to add more IPs, create a virtual interface or something like that.
And that's why I'm asking whether that can be bridged or switched, or so that I can have all the, when you call.
So what you can do is not technically bridge, but when you expose port, you can tell it what interface it should bind to. So that port flag which I was about to pass, that in that port flag you can specify, okay, if you have 10 IPs, use this IP, port, map it to this particular port, and then you have, say if you have 10 IPs, then practically you can have 65,000 into 10. Yeah. It's not technically a bridge, but it does extend your limit.
Yeah, but you would actually,
Yeah, you have to build some.
hypervisor and so.
Right, you have to build some sort of, I suppose, automation around it to detect what all IPs are there. And yeah, I understand that's a pain, but I think going forward, people might be, improving on network strategy. See, Docker claims that it's not a production-ready software. Many people are running fully into, Docker. Like Spotify has totally invested into Docker. RHEL has massive investments in Docker. So eventually, when they announce that we are production ready, I'm assuming that all these problems will be solved.
There is documentation that's dealing with creating your own bridge instead of letting Docker create it for you, and I think that might be that problem. So you can just bridge all the virtual interfaces into the public area.
Okay, so
That's on docker.com/articles/networking.
that might help. Okay, anything else?
I have a question.
Yeah, please.
Do you know how the IDs are generated? Are there some checksum or something like that? And if we both pull the same container and touch the same file and commit it, will the image have the same ID, the same checksum, or is it some randomly generated stuff?
Yes, the checksum would be same.
It will be different because there is a time in the metadata which changes.
Yes. No, so
It's based on the payload of the image, which is the data. Then there is a metadata, and there is, I think, something else. I'm not sure. But I think there are three parts, and there's one part metadata which is time when the image was created, so it won't be same.
That won't be same, like you said, that since metadata would be different, but I'm again talking about a very controlled environment. If he does exactly the same step, then I think it should, because the algorithm is the same. Of course, if there's even the slightest variation in time or something like that, then it won't be because of metadata, right? You're right.
You will end up with the same data in the container, but with different ID.
With different IDs.
Yeah,
Yes.
but it's not randomly generated. It is a checksum of some data.
Yeah, it is.
It's a checksum.
Okay.
Okay. Before we go ahead, okay, let's try to build a. I'll try to build the BusyBox image from scratch without any Dockerfile, and that will give you a fair idea. Okay, go ahead.
Where are the Docker images located on the hard disk?
Where spool something, where spool Docker something like that.
I have one more question. How Docker behaves during reviews? Do you have images running? Does it preserve it?
Yep.
Or do I need to start on
No, so I just did a stop and start, right? So the data is preserved. Stop, start, or reboot, it doesn't destroy data.
I mean reboot of the system, not the image.
Reboot of the system while the Docker is running, it should preserve the data because theoretically when you shut down a system, all the services are shut down, and so will be the Docker. Docker will also go through a shutdown, and it's going to preserve all those things. But when you boot up back, when you start the Docker binary, Docker server, it won't be starting the images on its own. So either you have to write some sort of automation to do that, or you have to manually start the Docker container from its stop state. It will be in stop state when you come back after.
So basically, Docker doesn't support auto-starting images during the boot of the system.
Not that I know. After reboot, Docker binary itself will start because of systemctl or sysvnet, whatever you choose. But as soon as Docker binary starts, it's not going to start the containers which are in stop state, because there can be a lot of containers that are in stop state. It's not going to auto start that for you.
Will it preserve start-stop state over reboot? So if I start in the container and the host goes down, host goes back up again, will I have to start it manually or?
You have to start the Docker container manually, yes. The data will be
I'll
there.
just roll my own service files for each of my Docker
You
containers.
can write some sort of automation, of course, put it maybe rc.net or somewhere where it can auto start. Again, like what I said, the Docker server will start automatically due to sysvnet or systemd, whatever you choose. But starting Docker server automatically doesn't start your Docker containers automatically. That you have to do manually or via script for now. Yep.
Is it possible to migrate running container to collaboration?
Running container? Not sure. I don't think so. You can take a commit without disrupting the commit, without disrupting the container, and then move that committed container to another machine. But you cannot just plug this one out and plug that one in. But I suppose taking commit and then moving the container is practically the same. The commits are actually very lightweight. Anything? Yeah?
I've heard about some plans to use OS3 with Docker. Do you have some details about this? Or
Can you come again?
I've heard some plans to integrate OS3 and Docker.
OS3 and Docker, no, I'm sorry, I don't think I'm the right person to comment on that.
I think that's Project Atomic.
Yeah,
It's on Project Atomic.
it's on Atomic. There is RPM OS3 which we have made, and there is still huge discussion going on around Fedora and in general about Atomic and OS3. Not the right guy. I'm topic. Okay, so anything else, or should I move ahead?
Well,
Okay.
just set up the interactive, like if I ship a short burst server, a particular one, and ask like an administrative passage from you, doing a Docker Docker run.
From Dockerfile, you want interactive inputs?
No, from a Dockerfile, not from an image. But as soon as you run it, you first need to set it up.
I don't think image will give you something out of the box. I can imagine that while running it in interactive TDY mode, probably the first pop-up that can come up to you would be fill up this detail, something like that. Another idea would be to, write a, so you saw that there is a CMD there, right? CMD Redis server. Instead of that, you can have a CMD initial setup. So as soon as the Docker is booted up, it will give you the prompt to supply whatever details you want.
Yeah.
And then you can take it ahead from there.
Yeah.
Okay.
So it's not being so particularly useful. The command that you need to run before that in your apps.
No, so
Create it as a separate image would not be as useful.
yum install and all will already be done before, or maybe instead of giving here a command, you could give a shell script that also works. So it will run all the yum update, it will clean up all the metadata repos and everything, and then it will give you the prompt to supply whatever information.
Sure. The diff would then be two commands. Yum install the application and set up application, which is easy enough to do. You don't need to make a separate image for that.
Okay, yeah, maybe. Yes. Right, so there is, when you build up a container, I think the only way of interactive entry right now would be the CMD, or maybe you can specify a shell script or something like that, which is already there in the Docker. So while you are building it up, maybe you can put a shell script there and then execute it during the initial first run. So that's one possibility. I'm sure there would be another more creative ways to do this. Anything else, guys? Okay. So let's try to build up the BusyBox image from scratch without any Dockerfile or anything. Cool. Okay, I think I've been blabbering since very long time. Do you guys want a 5-minute break or something? Because many of you look very sleepy right now. Would that be good?
Yeah.
Okay. What's the time? It's 4:15. We started maybe 4:20 or something like that. Right? Okay, we'll start in a couple of minutes. And I figured out why that Reader's 4 was not working. So I should do that as well. Okay, should I continue? Okay, like a few minutes ago when I was starting the Redis container which we built, it was not able to bind to the port, right? So the problem that was happening is that I need to tell Docker what port I want to map to which port, right? I didn't do that. So that's why while the port was listening on the other side, inside the Docker, I didn't have an equivalent mapping on my machine outside. So for that, now when I'm gonna run this new machine, run this container again, I'm gonna give it a port mapping. Okay? Minus keys for port mapping. Let's do this. Okay. So now if I try to tell it on this, yep, this time it works. Another way to verify that this actually works is when you do Docker PS, it's gonna tell you that in my local machine 0000:6379 is actually pointing to 6379 TCP port of Docker, right? So you can check from here as well. Yep.
Is it possible to map a port that is lower than 1024? So, for example, if I
it is possible, of course. That's what we do for Apache and all. We map port 80.
Yeah. So I can run, for example, DHCP server.
You can.
Okay.
Only catch is that only catch is that you have to do it via root. If you are doing it via a user in Docker group, then you might not be able to do that.
Yeah, that makes sense.
Yeah, so yeah, that's the only way. Okay? Okay.
Can you implement the IP tables forward rule that is associated with this?
IP tables rule? Let me just
You
see.
have an IP tables map table.
Yeah.
You have a forward chain.
Yes, I would have.
Thank you, firewall.
I think there is no rule like this.
There is.
Oh, really?
Yeah, so it's anywhere destination, open 11.
This one?
Yeah. Can you influence what sources, especially what sources might be allowed?
What sources might be allowed?
Yes.
Right now it's I'm assuming that you can modify that. Anyways, it's IP table, so even if Docker cannot do that, you can do that outside. Right? That should not disturb the...
Yeah, of course, I speak IP tables.
Yeah, so you can do it outside the Docker as well. I'm not sure if Docker has any wrapper or anything around it to do it from Docker itself. From what I know, the port flag, you can create mappings between ports. Not between. It's not a full-fledged. Docker isn't a full-fledged firewall, so it doesn't do the mapping of the sort of that. Okay, only allow using this IPs from this.
Can I do firewalling inside the
Yeah.
container?
If IP tables is installed. For example, if I'm doing for a BusyBox container, then IP tables is not there, so you cannot. But if I'm using a full-blown Fedora image or something like that, then you can. Depends what kind of firewall you have inside already. Okay, so that's one mystery less. So let's build a image from scratch. The idea is that Docker images are kind of OS tree. So it's a tree of what all directory structure you want. You tar all of that, and then Docker creates a container out of it, an image out of it. Okay. BusyBox is fastest thing to do, so I'm gonna tell you how to do that. So let's go ahead. First one is create a temp directory for your temp directory or work directory, whatever you prefer to call it. Right. Once you have a temp directory, cd into it. Use the yum downloader to download yum binary, download yum package and extract it. Visible? All of you got yum? Of course you have got yum. All of you got VisBox, the RPM? Okay.
It's not that fast.
Yeah, that's what I was afraid of. Okay, assuming that we're done. Next, we'll extract the contents. CPI, RPM to CPIO is used to extract the contents of RPM and write it on a disk or traditionally tray drives, but these days disks. So you just extract the RPM contents. Okay. If you can look at this is SBIN, this is USR. Oh god, syntax highlighting is hard. Backslash? Like this?
It's the anti-alias.
Ooh, that's nice. Okay. So we've got SBN, we've got USR. Let's first remove the RPM because we don't need it. Okay. Right. Now, how many of you know what BusyBox does? You guys already know, right? BusyBox is a tiny binary. For those who don't know, BusyBox is a tiny binary which creates a lot of symlinks and provides you basic functionality like ls, echo, things like that, touch and all those things. So basically, it's one power pack binary. Yep.
BusyBox Docker is available only for Shell's 64 architecture.
Yes, only 64-bit architecture.
No 32.
No, and it's not on roadmap. So I don't think there will be a 32 ever, as far as my knowledge goes. Yep.
What about Docker on ARM?
Again, not the right person to talk about that. But ARM might actually be possible once we have, servers powerful. Now we have servers powerful enough, so now it's a possibility. A year ago, I wouldn't have said yes, but now it's a possibility. Okay, so now what we are going to do is we are going to create all the symlinks. It's a tiny shell thing which I have written. So it created all the basic things which I need, like wget, wc, head, tail, all those things, right? So once you extract all the links, those who want to see the command, this was the command. Typing with one hand is very difficult. Yep, so this was it. Right? It will generate your entire tree with the right paths and everything. evident in here. So once you have the entire file structure ready with you, all you need to do is tar it up. Okay, create a tarball and then supply the entire tarball to Docker import. Docker import takes a tarball, creates a container out of it, and that's it. You'll have a Docker image ready to go. Right? That's it. I just do a tar -c and put the entire thing to the Docker import command, and my container would be ready to go.
Wow. If I'm going to layer these containers and one of these depends on the other, are there any tools that ensure that I have everything I need in regards to RPM dependencies installed in the pod?
Yeah, yum dash install.
Yum dash install.
Yeah, but it's all
that you're going to tar up. It will resolve the dependencies.
So I built I have my basic lowest container, and then I run that,
And then you incrementally build over it. Layering is cheap. Layering is very cheap. Unfortunately, for now, we are not using layering properly. We are using device mapping in Fedora, but we are working towards it. We will eventually have the AUFS, which would be very light. So that will be very cheap. At this point in time, I think when I last talked to Matthew, around 100 layers and the Fedora image will bomb out. So we have to do it anyways. Imagine your code breaking after you do 100 deploys. Not a very pretty sight. So okay, we are working towards that. Partly because as somebody there said that it's not supported in kernel right away. AUFS is not there, whereas device mapping is there. So we are right now using device mapping. Okay. See, I've got it. So that's how you can create a new image out of nothing, just from the file structure, whatever you have. So that's the end of the demo for me. I will, however, take another minute to signify these things. All of you downloaded my BusyBox. That was a backdoor to your devices. Thanks. But yeah, if you don't trust the person, do not download the image just like that, especially in new production. Try to download official images as much as possible. They are the ones without username / security updates. You're still on your own. If you are downloading any image with tag latest, that does not mean that it has latest updates pre-installed. That's a very persistent query from people that, oh, I've got the latest image. No, you didn't. You got the latest release. After that, there have been security changes. So just make sure that you always have the security patches and updates on your own. And there has been a potential risk, especially in multi-tenant environments, that it is possible to exploit non-namespaced devices from a Docker to gain root access. Right? That is a possibility. For Fedora and for RHEL, we have SE Linux policies to prevent that. So if you are turning off SE Linux, or if you are not taking your SE Linux warning seriously, then it's not good. There is still a potential risk that there can be a breaking of devices via kernel. Cool. Anything? Any questions and doubts? Yep. Oh, okay.
What's the risk of running untrusted image?
Sorry,
What's the risk of running an untrusted image?
your machine is mine,
Okay.
along with your data.
There's no protection in Docker.
Still your machine is mine. If you're running an untested image, the best thing that can happen is that your image will not start. That's the best thing. The worst thing that can happen is that the image is going to expose ports on your machine. Once the ports are exposed, the image has got entire computational power of your machine, your network. It can be potentially damaging, and what all frauds and bad things I'm gonna do, it's on you because it's your network, your machine. I didn't do anything.
Okay, if I was running an untrusted image in a virtual machine, I can just shut it off and...
See, okay, let me put it this way. When you run an untrusted image over VirtualBox or KVM or something like that, at the very least, your resource utilization is limited because of hypervisor. Hypervisor, it's very, very, very difficult to break through hypervisor and get the root access of the host. It's not so difficult still, but not so difficult to break the non-namespaced area of the kernel and get access of outside host. So that's the potential risk between the two. The isolation is reasonable if you trust the images and if you're not running on a multi-tenant environment, then I would say go for it. Docker is the best bet. But if you have a multi-tenant environment or if you do not trust the image, be very sure what you're doing. Make sure that SE Linux is always on your host machines. Take precautions. Yep.
And what about SE Linux and Docker? And what about SE Linux and Docker?
There are policies, we are supplying default policies to help prevent the mishaps and the breaking of non-namespace areas. There are policies already there in Fedora default SE Linux. So as soon as you download Docker, those policies are bundled together. You don't need to worry about it too much if you are on RHEL and your SE Linux is on, unless you find a new vulnerability.
So with the BusyBox, is it that is it just a basic and the most simple example that because there is no systemd and you basically run the BusyBox as init?
Yeah, so BusyBox is the simplest example I could think of. The reason is that I would have loved to give the entire demo on a Fedora image, but downloading Fedora image is at least 300 MBs.
Yeah, I know, but for example, if you want to do an Apache Docker container, like running HTTPD, do you need systemd in that image or?
You don't, no. You don't need it. It's good to have, but you don't need it. I would like to share a simple story. Not a story actually, it's a... So what happened with Fusion Passenger guys? You guys know Fusion Passenger? Right? Right, so they used to do the simple thing, they used to just run the passenger in a container. And what they figured out was that the plain container, if you try to run something in it, it doesn't have anything. It doesn't have syslog in it, it doesn't have syslog, it doesn't have any of the supporting things. So they have created a base container for themselves which have all the basic things like syslog, audit, and all those things pre-installed, so that they have some amount of things. The biggest problem what happens is that if a process dies, since there is no init process inside the container, if the process dies, there are like zombie processes running around. There's nobody there to read it or to repair it. So that's a major problem in Docker environment. And when we say official image, download the official image, don't run it from anybody else's untrusted environment. The reason we say that is because when we ship out official image, we take care of those things. We have a init process so that things are easily reparented and there are not zombies running around and all those things, syslog and etc. is taken care of.
Okay.
Anything else? Yep.
So Docker diff shows the diff towards the base, right?
Right.
Can you explain how to look into layers and understand what they contain and the differences between the two layers?
How to look into layers in the sense you're talking about comment diffs.
Yeah, what does each layer have? Like what different layers?
Right. So each layer, for example, what we saw in the Redis container building thing, each step or each layer generated has its own ID. So whenever you do a Docker diff and the container ID, it will give you the right diff. You don't need to always look at the last one and check the diff. You can check intermediate diffs by giving it the appropriate ID. It's very similar to GitHub. So what you do with Git is that you give it commit IDs, right? Whatever, say if you want to see the diff between yesterday and a week ago, then you give it those two IDs. So similarly, Docker diff works in a very similar fashion. You can give an intermediate Docker ID and it will work just fine. Yep.
Is there anything like method to sign an image or something? Just so someone outside, well, I guess you can kind of browse images created by you, and if I then say pull that image, can I somehow verify that it's actually from made by you? I mean, like I can do with an RPM package, I can sign it, give it to someone else, and he can check with my PGP key that it's actually created or at least signed by me.
Not that I know of. I don't think there's a way to sign off an image, at least as of now.
I think the standard is coming. I think the standard for signing is under development.
Okay.
I don't think it exists yet.
Yeah, but it's been thought about this issue.
I've heard people suggested to me that somebody's looking at there's last I talked to somebody, there was no clear answer in the entry.
Yep, as of now there is no. But that's the whole reason why Docker guys came up with this convention that user images should be user slash something and official images should be without the slash and all those things. There is no.
And the security of the official images is basically backed by the
Docker.
HTTPS certificates or something.
Security of that images there is SSL. I mean when you are downloading it's over SSL. Yep. So when you are downloading, the download happens over SSL. So that security is fine. The actual people behind those official images are designated Docker guys as well as the community guys. So from Fedora we will have someone, probably the cloud liaison or someone who would make sure that the right image is shipped to the guys at Docker, and then those Docker guys will make sure that the right image is shipped to you when you do a Docker. Anything else? Okay, looks like we are done. Cool. Thank you guys. It was nice talking to you. If you have any questions, you can catch me. Okay, cool.